All right, let's open up to 323. We have 4 more of these optimization examples to go through before the period ends. Before we start, though, I just want to let you know, I've already gone over this before, okay, but coming up next week, we have our schedule. Partner quiz on Monday, because we're officially done with the unit. Review day Tuesday. Test Wednesday, Thursday. How'd it go, Anush? We don't want to talk about it.
Saluj in history, he'll come down like after a quiz and be like, oh, George is 15, you missed like 2 every time.
Every time.
30 times. I hate it.
What is it? It expect the worst, hope for the best type deal?
Pretty much.
All right. Partner quiz Monday, review day Tuesday, test Wednesday, Thursday. Test day also means homework day, okay? Homework day, Wednesday. And then your first pass-fail day on Friday for derivatives. Yeah.
What is our review going to be on Tuesday? Like,
Just an opportunity to ask questions, work on homework problems.
Okay.
Use the whiteboard.
You could use the whiteboards. I give you, I forget what page it is. 329.
Okay.
There's some practice problems or the previous, like from the practice exams. You can work on those.
Okay.
Yeah. All right. Since our partner quiz is on Monday, I'll let you know who your partners are by the end of the period today. Okay. If I happen to forget because I get wrapped up in this, just remind me. But I gotta let you know who you're working with for Monday. All right. For example 6, the profit P in thousands of dollars for a company spending an amount of S on advertising is given by this function. Find the amount of money the company should spend on advertising in order to yield a max profit. This seems like a pretty important question, especially if you worked in a business, right? You want the most money, okay? So notice how it's an optimization type question. You want to find the most of something. What are we trying to optimize? Money, profit, value. Okay, so our primary equation, the main equation we use, has to represent profit. Do we have to create a profit equation? No, they're nice, right? They give it to us. All right. Are we in need of a secondary equation?
I'm saying no.
Why not?
There's
one variable, right? We're good to go. So there's no need to figure out some other equation to help us out. Okay, so from here, we don't really need to draw a picture because we don't have a physical object that we're dealing with. So we'll just take the derivative, set equal to 0, find a critical point, test it. We're good to go. Now, the derivative of P, you could write it as P prime, or it would be dP over ds. Like if you change the y's or the p to y and s to x's, it'd be dy over dx. So you could use that notation as well. Doesn't matter. Okay, so either one of those derivatives. Derivative of the right-hand side, negative 3 over 10 s squared plus 12s. All right, set equal to 0. How do you want to solve for s? Factor, so we can take out an s. Negative 3 over 10 s plus 12. Zero product property? Yeah. So if you're multiplying, aka a product, and your answer is 0, okay, 0 product property, you know that these two things you're multiplying together, at least one of them should be 0, right? That's why we break it up. So this solution would be 0. And then if you set the other one equal to 0, what would that one give you? Oh my gosh. So subtract the 12, multiply the 10, negative 120, divide negative 3, 40. Okay, so we have two critical points. We should try to think about, should we test both of them? Should we only test one of them?
Well, it's not gonna be zero.
Zero doesn't make sense, right? The company's
It's
not,
not logical.
it doesn't make any sense, right? You could be losing money at some place because it's cubic, right? You'd have some decrease in profit, right? This one doesn't make sense,
Either way, you start with 400,000.
right?
How much money you make?
So let's test 40. All right. So the lowest amount of money that we could spend on advertising is 0. We're going to test 40. And I don't really know the highest amount of money that we want to spend on advertising, so I'll just leave it as a question mark. $1 million? It could be.
It's like 60.
Okay. What are we feeling between 0 and 40?
I'm feeling 1.
1. All right. Plug it into your derivative. We'll have -3/10 plus 12. That's positive. What are we feeling bigger than 40? 41. Plug it in. You may need a calculator or reasoning through it. Probably negative. All right. So we confirmed a max. We will say profit is, yeah, thank you. Profit is maximized when S equals 40 because the derivative of profit changes positive to negative. Are we done? We confirmed a max. Did it actually answer the question?
No.
Find the amount of money the company should spend. They should spend
40.
$40.
40,000.
Let's see. S was in thousands of dollars. Okay, so spend $40,000. All right. Doing okay? Lovely. All right, let's flip the page. Oh, we actually only have 2 more. I lied. We had 3 questions to do today, not 4.
Let's grab it.
Okay. Example 7. Determine the point on the line y equals 2x plus 3. So they gave that to us in the picture. So that the distance between the line and the point 1, 2, which is off the line, is a minimum. So we basically got to figure out, do we walk this way to get to the closest point? Do we walk this way to the closest point? This way to the closest point? Okay, we're going to try to figure out what point on here is closest to this one. So what should our primary equation represent? What are we trying to optimize? Yeah. Distance, so that the distance is a minimum. So we need a distance equation. Hi. You want to start it?
What's that?
You want to start it?
I didn't finish my homework, you know. Do you mind if I?
You want to start it with turn in the homework later?
Yeah.
That's fine. You need a calculator? Here you go. Yep.
Why are you on that side?
I don't know. I think what happened was in the summer, it was cooler over here because of the windows being open. We get the breeze.
I just can't wait.
Also, there's only 10 of us, so it'd be really.
I know.
It would be more weird if we were spread out.
Well, see,
yeah.
my other AP class, there's 4 more. Okay, 14, but they're all spread out. So I'm looking this way, I'm looking this way, I'm looking this way.
I feel like that would be weirder.
It is very convenient, I must say, to have everybody here. You got my back, Jack, right? You got my back. Okay. Can we think of a distance equation that we can use?
VIT plus 1/2.
Distance for
Something
Yeah.
square root of y.
Aw, you
Something.
kidding me?
Nope.
Square root of x2 minus x1
Yeah, it's some sort of.
plus y2 minus y1
Yeah.
squared.
Dude, that's just ignorant.
Do you know where the
You always
distance?
say that.
Do you know where the distance formula comes from?
Quadratic.
Okay, the answer is 0.
Pythagorean
Yeah,
theorem. Yep,
Yeah,
Pythagorean
so am I
theorem.
right?
All right, so in this example, let's see. We have an x value of 1, which is the point off the line, and then we'll subtract the x value of whatever point is on the line. We don't really know that, so we'll just leave it as x. Then we'll add the y value from the point off the line, which would be 2, and then we got to subtract the y value from the point on the line, which we don't really know because that's what we're trying to find, so we'll leave it as y. So this is the main equation that we're eventually going to have to take the derivative of, solve critical point, sign chart, that whole jazz. Do we need a secondary equation? Yes, why?
Because we got 2 variables.
We got 2 variables. So somehow there has to be another equation we can use to help us replace either the x or the y. What if we use the actual equation of the line? Alright, so 1 minus x squared plus, okay, so if I am subtracting y, I should be subtracting this whole equation, which means I'm going to have to distribute a negative. So this would be minus 2x minus 3. Alright, so now we have the one equation. Maybe we'll clean it up first before we actually take a derivative. Let's see. I don't really want to do a chain within a chain. Do you see how that would be the case here? Because we have a square root, but then we have chains on the inside. I really don't want to do that. So I'm going to expand everything on the inside. This would be 1 minus 2x plus x squared. Now for this other factor, 2 minus 3 is negative 1. So I got to expand that. Plus 4x squared plus 4x plus 1. So altogether on the inside, 5x squared plus 2x plus 2. We can take the derivative of that, right? Chain rule. Bring the 1/2 down from the root. Keep the inside. New power. Negative 1/2. Finish the chain rule by what? Derivative of the inside, so 10x plus 2. Alright, can we clean it up? I mean, we'll set equal to 0, but can we clean it up? I have a negative power, so I'll move it to the bottom and maybe change it back to a root. And then the 1/2 times 10x plus 2, we can change that to 5x plus 1. Are we okay with that? I did a lot there with simplifying. So here's our derivative. We want to find a critical point. So can we think about when this fraction would equal 0? Negative 1/5. Okay, so that comes from the top. Now, we did have another piece of the definition to a critical point. That's where the derivative is 0 or undefined. So we should check to see if there's a spot that would make the bottom 0 as well. So if we check the inside of this fraction, or not fraction, the inside of the root, if that would ever be 0. I don't think we can factor that. So how else can we check it? Quadratic formula. Okay. Now, we're not going to do it. I just want us to think about it. Okay. So the big piece of the quadratic formula is the b squared minus 4ac is like that square root piece that dictates if it's imaginary or not. So let's check that out. If we did b squared, which would be 4, minus 4 times a times c, that's definitely going to be negative, right? So if the inside of the square root of the quadratic formula is going to be negative, what's that telling us? It's never going to be 0, right? We have an imaginary solution. Okay, so this is our only critical point. There's no number that's going to make the bottom 0. All right, so let's test it. The lowest x value might be negative infinity. I don't know. Maybe use a question mark. And the highest x value, again, I don't know. Maybe it might be positive infinity. Use a question mark. The big idea is that we want to test something on each side. So what are we feeling a little bit to the left of negative 1/5? That would be in the other interval. Okay, negative 1. If we plug in negative 1 to our derivative, top would be negative, bottom would be definitely positive. All right, so that's negative overall. And then maybe 0 for the other interval. Top would be positive, bottom positive, so there's a positive. So we confirmed a min. All right, I'm running out of room. I'm going to go down here. Distance is minimized when x equals negative 1/5 because d prime changes negative to positive. Are we done? No. What did we need to answer though? The point. Okay, so we know the x value is negative 1/5. How can we figure out the y value? Plug it into the which equation? We have a lot going on here. Y equals 2x plus 3. They want the point on the line. Okay, so negative 2/5 plus 3. Common denominator of 5, that would be 15. Be 13/5. All right, there's our point. Yeah.
It's like, it's on topic but a little off topic at the same time.
Okay.
So what happens if, I'm guessing you just say it's like no solution, but if the sign chart just says like max, you have a max of a min, and you're looking for a min, you just say no, and that's the end.
So if that was the case, like if this was a max and they want a min, then if they gave us a closed interval, we'd have to test the endpoints. Like by the extreme value theorem, there'd be a minimum somewhere else. But if they don't give us a closed interval, we might have to say no solution or not possible because we aren't able to confirm any other value. Does that make sense? Yeah? Yeah. Are you, so let's see, negative 1/5. All right, so how'd you do it? Opposite reciprocal slope, right? So that'd be negative 1/2.
It would be the smallest, shortest distance to the line. Straight line, dude.
It is a straight line. Okay, so how did you get this point though? What did you do with the opposite reciprocal?
I put y equals negative 1/2 x plus b, and I plugged in the point 0.
And you plugged in that. So you got 2 equals negative 1/2 plus b. So this would be negative 4. So y equals negative 1/2 x minus 4. So how did this give you that point?
I graphed it on the intersection.
Let's use a calculator. Yeah, okay. What if you didn't have a calculator? You wouldn't, okay. All right, so there might be a way to get around it without calculus. Okay, I understand that. You guys didn't you guys do the box example without calculus? Some of you did like guessing and checking?
Yeah.
Okay, so it might be possible. I'm just trying to show you how we could get there with calculus or without a calculator. Okay, another way to confirm your work, if you want to check it out that way. All right, so I guess based off this graph, we're somewhere right there. All right, which would be a perpendicular line. All right, good job. Let's try our last one. All right, a rectangle ABCD with sides parallel to the coordinate axes is inscribed. That means inside of a particular region. And we're inscribed by this parabola. Okay, they give us the equation. Find the x and y coordinates of point C so that the area of the rectangle is a max. What's our primary equation? What are we trying to optimize?
Area of a rectangle.
Area of a rectangle. Okay, so we got to figure out the area formula for this rectangle. Now, since we're dealing with a coordinate system, like a graph, we know that the origin represents 0. So if we go out some distance on the right, that's representing an x distance, and it seems like we would have the same distance on the left as well. And then the height, we don't really know, so maybe we'll just label that y. So the area of this rectangle would be base times height, so 2x times y, 2xy. Are we good to go with our derivative, or do we need a secondary equation? Secondary, okay, because we have two variables. What could our secondary be? Probably the one that gives us, right? The equation of the parabola. So area equals 2x times negative 4x squared plus 4. I would definitely distribute before taking a derivative. You could do product rule. Not saying you can't, but it might be easier if you cleaned it up first. All right. Derivative. Negative 24x squared plus 8. Set it equal to 0. Solve for x. So subtract 8, divide negative 24. We get 1/3. Square root both sides. We get plus or minus 1/3. So technically 2 critical points. Should we check both? We have to check one. Why?
Because you can't have a negative.
Why can't it be negative? You can go this way, can't you?
Whole lot. Negative.
Yeah?
If it's distance, like you have to take the absolute value, like it can't be negative.
Well, see, this one was distance, right? But here we're talking about a coordinate. So you could have a negative x value coordinate.
You only have to test one because it's squared.
What's
Either way, it's going to be positive.
what's squared?
Never mind. I saw a 4x
Yeah.
squared
I
actually.
mean, didn't we say that x was the positive distance and then multiply that by 2?
Okay, so x, we're assuming x is this positive distance, and then we have the same positive distance this way. But they want us to find the x and y coordinate. So a coordinate could be negative. I know the square root of 1/3 is a distance, but in terms of a coordinate, it could be this way.
I say we just play it safe and check them both.
Oh, wait, we're looking for point C.
Point C. Where's point C?
Oh,
Positive or negative coordinate?
positive.
Positive. All right. So we only have to test the positive one. There you go. So I don't know. 0 to square root of 1/3, square root of 1/3 to something else. Okay, make a sign chart. We might need a calculator for this one. I don't know what the square root of 1/3 is.
0.57.
0.577. Okay, so maybe 0.5, something a little bit to the left. So if we plug in 0.5 into our derivative, 0.5 squared is a quarter of negative 24, negative 6 plus 8, positive. Something a little bigger than 0.57, 1, plug in 1, negative. All right, confirmed max. So area is maximized when x equals square root of 1/3 because derivative changes positive to negative. Are we done?
No.
No, what do we need?
Point.
Point C. All right, so x coordinate, square root of 1/3. How do you want to figure out y coordinate?
Plug in the original.
Y equals -4x².
All right, the equation of the parabola, right? Because C is on that curve. So let's see. Square root of 1/3 squared is 1/3 times -4, -4/3 plus 4. Get a common denominator. This would be 12 minus 4. Would be 8. And then keep the common denominator of 3. There we go. All right, officially done with Unit 5. We have about 12-ish minutes left, so maybe try some homework problems, ask questions if you have to. Give me a chance to bring up your partner.